This is the first video from the November 13th class. We're really focused this week on advanced techniques in raster. So last week we learned about the basics of raster. The cousin to vector, the other primary mechanism used to conduct spatial analytics. Vector being points, lines, and polygons, discrete objects, not discrete like hush hush, but CRETE. Differing objects, point, line, and polygon represents each. And raster being space, right? Breaking the world up into a series of grid cells, with each grid cell representing some value. That value could be something categorical, like land cover, like we learned last week, where a 1 might mean urban or a 2 might mean farm. It could also be linear and continuous, like elevation or distance, right? Where each cell would tell you how far away it is from a thing, or each cell would tell you how high above sea level it is. We learned the basics last week, how to create them, how to put them together, really so that this week we could learn a few advanced mechanisms for them. Now, I'll say the same caveat I said last week. If you have the availability, absolutely you should take Dana Tomlin's Modeling Geographic Space class. It is the best GIS class I've ever taken in my life, and it is a deep dive into raster and what it means. I won't go as deep today, right? I'll give you a couple of practical tools that I think are valuable, and that if you can have some familiarity with, you could expand your ability to model urban, rural, forest, etc. environments, right? The tools I'll teach you today can be good for real estate development, for demographic modeling, and then even for conservation of sort of land and forest and farm and such. So this first video is really going to be a two-parter that's about surfaces, because this is one of the most common uses of raster is to model a three-dimensional surface, right? So you'll take a grid pattern and you will turn it into each cell representing a value of elevation. And the way that we're going to learn to do this is with something called Lidar. Now, some of you may know what Lidar is. Lidar is used when there's a device, typically from a plane, that is flying overhead and shooting millions upon millions of blasts of radar and infrared at the ground. And they bounce back, and when they bounce back, they can bounce back and say effectively the type of surface that they hit, and more importantly, the distance between the plane that dropped them and where they hit, and that can give you the elevation of something. And these LiDAR points end up creating what we call a point cloud. And this is always a fun thing to describe. I always think of, like, imagine you were standing outside and like a swarm of bees or flies or locusts descended upon you and covered you completely. Well, anybody around you would see a series of flies, but they would be in your shape, right? They would be in your contours. You'd see your arms and your legs and your face. That's what LiDAR is. It's like swarming the world with millions of dots. Now, if you're going to follow along with me, I have something in your folder here called All LiDAR in the raster tools folder. We're going to use the same data set that we used last week, November 6th. So if you're to drag in the All LiDAR data set, the LASD, that we'll learn about how to create in a second, it doesn't look like much at first, right? It looks like sort of a series of grid cells. They're not grid cells. Really what these are is sort of LiDAR blocks. And we'll learn in sort of the next video briefly when you sort of want LiDAR for yourself. I've given you some here, but if you want to go and download it, you typically will need to get, you'll need to download it in segments, and the reason is because there are millions and millions of points, and you can start to see them when you begin to zoom in on something. And so I'm zooming in, and when I pause, the grid pattern will disappear, and suddenly I'll see all these points. Millions of millions of millions of points. And it doesn't matter how many I'll see, right? In a second, it's going to tell me my data percentage. I'm not even going to have a fraction of them, right? If it even does report 4.5. I am seeing 4.5% of the points. And what do I mean by the points? Well, I mean each of these points represents a value from the darkest of blue, which is roughly around 0, to the reddest of red, which is 581 feet, which tells you your distance above sea level. And that is a Lidar cloud, is what they're called. Now, the cool thing about Lidar clouds, and I'll show you how to create them in a second, we'll talk about this a little more, but if you also drag the buildings in, right, these are all sort of buildings, and you can sort of see the shapes on the map, right, notice that we don't actually seem to have any on top of the buildings right now. If you highlight your Lidar data set here, and come up to the three things that were created, appearance, data, and classification, and come to come to appearance, you'll see under the LAS points here, you tend to have these two options, right? You can talk about these, but the two that matter most, I think, are all points and ground. What that means is that when LiDAR is created, it knows whether what it's hit is sort of an aberrant surface like a building or a tree or a bird that's flying by, or whether it's the actual ground. And that's critical because the ground, if you map that, that just tells you the base elevation, right? That's maybe how you calculate the slope or how you understand how water might flow. But you could put all points and then it would topographically lay them also, as you'll see, on top of the buildings. Why is that important? Well, there's these fascinating tools that I'll briefly show you in another video, but that we're not going to talk about in detail in this class because they're more advanced techniques for modeling geographic space. But if you know not only the elevation and the terrain, but also the height of buildings, you could calculate really cool things like viewshed. You could learn where you might be able to see something or where something could see you based on the height and elevation. So that's LiDAR. Now, what we will eventually do here, because this is a raster-based video, is I'll show you how you can eventually use this to not simply run some surface analytics, but here under data to go to export and turn this into that same raster-based elevation grid that we had last week for Lancaster when we were looking at the raster grid. So I'll stop this video now because it seems thematically appropriate, and then we'll pick up at the next video, and what we will do in that one is we'll actually learn how you build this LiDAR data set, and then we'll see sort of what you do with it once it's built, how you can analyze it, some of the beautiful things that you can do.